Okay, Assalamualaikum and good morning. So sorry, right? Okay, I went to James. Okay, we will start in roughly about, I think, one more minute. It should be, I believe it should be 80. Currently, I have only 22. All right. I just marking your test until question number 4. And so far, not that good. Okay. Mostly the question, if it is C1 and C2, you can answer it, right? And don't get me wrong, okay? I believe you spend most of your time to search for the answer. So it means that you never understand what we have learned so far. You are mostly after memorizing all the facts. All right, I have told you before, and I'm keep telling you again and again. The problem with this course, we don't have specific textbook. You need to go and read, okay, what ever ebook that I given is not enough. Okay, currently I have 34. Today we will cover the second OS, which is Linux security. Okay, as usual, we will discuss mostly about two things. When we want to discuss OS security, we need to focus on two things. Okay, security, which is a defense mechanism against of the outsider threat. Okay, with that we are looking for authentication. Okay, and secondly, the defense mechanism, okay, against internal threat. In OS we call it protections. Okay, we will look how Linux handle the authorization. Okay, right? Unix. Okay, it started with B, I think. Okay, and in 1975, okay, Unix being written in C. Okay, before that it called B. All right, and then it C is the they call it not high level language per se because it is a mix between assembler and high level language. Okay, but what it means, okay, we can recompile and install at other hardware. These years, those years are very very close technology where the OS actually is being built for a specific CPU, right? Not that open. By writing the OS on high level language means it become uh, 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 portable. What we need to do is just recompile. Okay, right? Okay, okay. Somewhere here, where in my model? Okay, somewhere here, right? Someone after tennis bound, okay, create Unix for Intel CPU, Intel 86 CPU, and it called mini Unix or Minix. Okay, Linux use Minix source code to create Linux. Okay, Google use Linux as their base to create Android. Okay, in Linux, we have desktop that represent GUI aspect of the OS. Okay, in Android, they call it launcher. All right. Apart from this, okay, we have BSD, Berkeley Standard uh, 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 Berkeley Standard up to distribution, all right, which Nextcube used to create NextOS. Okay, from BSD Unix, it went to March 3 OS, and from there, okay, Nextcube create Unix variant. They call it NextOS, NEXTOS. So when Apple bought over Next Incorporated, they changed it to Mac OS 10 X. And based on that, we have iOS, iPhone OS. So if you are using Android, if you are using iPhone, right, you are actually using Unix. But different architecture. Okay, right? Does Unix have security architecture? The answer is no. Why? No, because the main idea in Unix is for research and development. Most of the source code was given to the universities so that they create their own. That's why we have, okay, BSD Unix, which being released by uh, uh, Berkeley uh, uh, oh, university. All right, but mostly the security features came from Linux. Okay, came from Linux. All right, but this means the implementation is not that up to professional, because it being created by open source community. That one thing. Okay, and that why you have some security architecture that be implemented in different Linux distro is a bit different from one with the others. Okay, and the second thing is it is an open source project. So attacker can view the source code and study all the weaknesses of that particular security architecture. So we need to know this. Okay? Some of you argue that Linux is more secure than Windows because in Windows there are a lot of attacks. But in reality, Linux is worse than Windows. Okay, why? If you are attacker, right, you need to create an impact. Which have the most installation in the world? Windows. So that is your main target. All right, line of defense, there are two. Okay, password authentication. This is what in CSC662 we call security components, where we provide protection from external threat. Okay, we will study how this process, okay, implemented in Linux. All right, the other line of defense is file permission or authorization or access control. Okay, how it being implemented in Linux. These two. Just focus these two. Okay, right. Likewise, we will go through basic thing. Who is the principal? Okay, principal can be a user, okay, or a machine. Okay, if you are a user, okay, you will be given user ID. Now you should start relate with Windows security. All right, okay, user ID or UID, and it has group ID or GID. Okay, it's stored in etc group. Okay, there is one group ID in etc password that we call up to primary group ID, where you create an object. Okay, that particular group ID will be the main group ID, which Linux will assign it to. All right, but you can be at most 24 groups. That information is stored at etc group. Okay, I want to mention now, okay, in Linux or Unix, everything is in text format or ASCII format. ASCII. ASCII format means if you have this, if you have the right, you can see. They will treat it as everything as a file. flat file. Okay, that one thing. Okay, password encryptions. Right. Okay, when we create user account, okay, in etc password, okay, it will assign two things: user ID, group ID, and the other thing is password. How Linux improve this? Okay, remember in Unix, everything in plain text. Means if you have the right, you can see, you can read all the password. Okay, right? So to provide confidentiality, what is confidentiality? Authorized disclosure of information. Okay, what is the mechanism? Encryption. In Linux, it will encrypt the password. In Windows, the first technique that they apply is hash function. The second technique they apply is encryption. All right? And this encrypted password is stored in etc shadow. Okay? etc shadow. Why they create a new file? Because they want to retain unique structure. Okay, so now, okay, every single etc password you have this symbol. Where is that symbol? This one means Linux will look, okay, at the encrypted password in etc shadow, right? Okay, now there is possibility that there are two or more users having the same password. The same password. So you use the same password, you use the same key, you use the same crypto algo, you will get the same encrypted password. So to have different encrypted password, this password will be added sort value, normally 2 bits. Okay, 2 bits. This sort bit will be added to password. All right, and these 2 bits are unique. Okay, it can be from your user ID or it can be from your it can be after randomly after generated. Okay, now the Linux will allow users to have same password, but it has different encrypted password. That's good point because every encrypted password now is unique. Then the attacker will have after difficulty to know what are the key. What is the key? Okay, that one thing. Disadvantage of this, we need to store this sort value somewhere. Although it's too big, okay, 1 0, Okay, but when it involves like us, 180,000 students, it is a lot. So disadvantage of it, it require additional storage. The advantage, it become more secure as it allow user to share the same password and yet will produce different encrypted password. Group file, okay. This is the syntax. This is the group name. And these are the group member. Okay, right. Why it is important? Because Linux will use these two, etc password and etc group, to enforce their authorization. Okay, we will discuss this further. All right, that's someone. Okay, root privilege. Okay, in Windows, we call it system administrator. In Linux, they call it root, R-O-O-T, because it started from the root. And the root ID is 0. Okay? It can do literally anything, everything. Because if you are the root, the access control mechanism means authorization will not be enforced to you. All right? Okay? And then we can be administrator. Okay? And means that we can use root to install, delete any software, and can change some system the properties like time, clock, and date, and so on. Right? Some restriction, okay, cannot write to read-only system. Okay, but to overcome this, we can assign to full access, means read, write, execute, and then remount this volume. Remount means, okay, putting the file system, loading file system into memory. That is mounting. And when we remove it, okay, we copy back all the file system to the hard disk. We call it demounting. Right? Cannot decrypt password, but we can reset it. This is something happen in Linux. In Unix, anyone can be root. Not R-U-D-E, R-O-O-T, root. As long as you know their password. Okay, there are two commands. Okay, SU means super user. Okay, SU, when you enter, you need to enter root password. Okay, all right. Now, next command is sudo, S-U-D-O. Okay, sudo mean, okay, you want to run as something, as root. Okay, let's say you want to run XYZ. okay, sudo xyz, and it will prompt you to enter root password. Means you can run, everybody can run, all right? Root or super user. Okay, to me minimize the issue. Okay, what we can do actually, we can assign, we can configure certain PC or certain terminal can run su or sudo. So means not every single PC client or terminal can run it. Any of the specific hardware. This is how we restrict su and sudo command. Okay, that is how we control the invocation of su. Right? Subject, again, any active process in run by principal. Okay, in Linux, like Unix, it has three, okay, fork, vfork, and exec family. Okay, I will not go through in detail, but these are when we create child process. This is the command that we need to create child process. We have virtual right? Vfork means we create child process using the same address space, right? Okay, and then we have exec that can change the command. Okay, all right, and okay, this every single object will have user ID. Okay, we have two real user ID. Okay, this is where the process inherit user ID from of the principal. Then the other one is effective user ID. This is means, okay, okay, it can be from the third subject. The third party subject means, okay, if we create child, that child can create, okay, another child process and it can inherit from that. All right. So we have to, but in reality, it doesn't care whether you have a real user ID or effective user ID, but okay, authorization will be based on UID and GID. All right, we will continue after this when we talk about object. Until then, thank you.